Hello, and here we're back again, and we are going to continue to deconstruct this phrase, the fit of the model with the data. And when we ended the previous presentation, we were talking about the model, and that's why you're seeing up here the model, because that's what we're transitioning from now, from the model. And next we'll be talking about the fit. And so with the model, what the model is, just as a quick reminder, is that it represents the set of predictor variables that you're testing. And out of that model comes predicted values on the outcome variable measure, which are based on person scores on the predictor variable measures, which are in the model. Okay, so that's the model in a nutshell. And now let's move from there to talk about the fit. So here I'm going to erase it in the fancy way. See, most people would use an eraser, but we kind of do it old school here. Okay, so I'm going to do it with my hand there. And oh, but look what happens when I do that, though. I start to get rid of these things. I guess there are a reason for erasers. All right. So now we're going to talk about the fit and what we mean when we talk about the fit. All right. Okay, now you all need to engage in an exercise with me. Now again, this depends where you are. If somehow you're like in a car right now and doing this or operating heavy machinery, you probably don't want to do this, right? Because it'd be dangerous. And I don't want to be responsible for things happening to you that are bad. I want you all to be here and with me and learning about regression. But if you're in a safe location, you need to engage in the following exercise because this is centrally and crucially important to your understanding multiple regression when you are building a multiple regression model. Because the goal of building a multiple regression model is to build a good fitting model. And that is a process, and that takes time, and you may take predictor variables out of your model and put new ones in, okay? And over time, you build a good fitting model. And crucial to the process of building a good fitting model is that you understand that there are two values on the outcome variable measure for each participant in your sample. Okay? So here's the exercise, and I just want you to kind of go with this like this. I want you to kind of get slow in your breath and close your eyes a bit, I suppose. That's what I'm doing now. And I want you to burn into your cortex this basic idea that there are two values on the outcome variable measure for each of your participants in the sample. Okay? So I just want you to just sit with that idea, because I never want you to forget it. That for each participant in your sample, there are two values on the outcome variable measure. For each participant in your sample, there are two values on the outcome variable measure. What I'm doing right now is I'm meditating on the idea that for each participant in your sample, there are two values on the outcome variable measure. Hope you're doing this, kind of getting relaxed and meditating on the idea that for each participant in your sample, there are two values on the outcome variable measure. For each participant in your sample, there are 2 values on the outcome variable measure. For each participant in your sample, there are 2 values on the outcome variable measure. All right. So I want you to just burn that into your brain. Because from that basic understanding, you can go from there and understand what is essential about the model building process in multiple regression. That for each participant in your sample, there are 2 values on the outcome variable measure. Here are each of your participants. Participant 1, participant 2, participant 3, participant 4, participant 5. And we go on here with more and more participants. And for each of those participants in your sample, there are 2 values on the outcome variable measure. There is the actual observed value that each participant, let's say participant 1, obtained on the outcome variable measure. When you handed out those measures, remember we did that exercise earlier at Theater of the Mind, where we gave a stack of 1, 2, 3, 4 measures, 1 on the outcome variable and 1 for each of our predictor variables. So a stack of 4 measures to, let's say, a group of 11 persons, including yourself, if you remember this exercise. And one of the measures you filled out was a measure of the outcome variable. And you handed all the measures in, and they were all scored, and one of them that was scored by the researcher was the measure of the outcome variable, and you got an actual observed score on that outcome variable measure. Or, in this case, participant 1 did. So we have their actual observed score or actual observed value on the outcome variable measure goes right here. We'll start filling this in later, but that actual observed value on the outcome variable measure, in this case for participant 1, goes right here. But you have a second value on the outcome variable measure for each of your participants. Again, now looking at participant 1. You also have the predicted value on the outcome variable measure for participant 1 from the model. From the model. Here's the model. From the model. Based on the participant scores on the predictor variable measures. There is from the model a predicted value, in this case for participant 1, on the outcome variable measure. And so this is true for participant 1, it's true for participant 2, participant 3, participant 4, participant 5, etc., across all of the participants in your sample. You have for each of those participants 2 values on the outcome variable measure. The actual observed value on the outcome variable measure and the predicted value on the outcome variable measure from the model. Okay, so you have for each of the participants in your sample their actual observed value or score on the outcome variable measure, the value or score on the outcome variable measure predicted from the model. And then you have the residual, or the error in prediction, or how far off that predicted value is from the actual observed value on the outcome variable measure for each participant in your sample. Now notice we have this interesting thing here, which I have not mentioned before, called the standardized residual. Now, a way that you can start scaring your friends and family from, let's say, you're in a statistics course right now, and they knew you in one way, and now you do the following, and you will scare them because they will realize that you are now becoming a quite different person, and they never expected to hear you say these words from your mouth. And when the day comes that you're doing this, you will know, and everyone else will know, that you have like gone native, that you have become like the real deal in terms of being a statistician, because you will put your focus on the thing that defines what is meant by the fit of the model with the data, and through which the fit of the model with the data is assessed. Basically, essentially, conceptually. And that is, you will say to your friends, your family, the day will come when you will say the following: I need to leave now, I need to go upstairs because I need to go ahead and examine the standardized residuals for my sample of data. Oh, when you start saying, I got to go upstairs now and examine the residuals, and what you mean by that are the standardized residuals of the data from my sample, then you have become like the real deal at that point. You're like, you now can wear the badge of being a statistician at that point when you're talking that way, because that captures the essence of how we assess conceptually, intuitively, by looking at our data, the fit of the model with the data. The multiple regression analysis will do its analysis, it'll provide its output, and it will do all of that, and it will be quite exact about telling you what the fit of the model is with the data. There are certain numbers you're going to look at, there's certain benchmarks you'll pay attention to, and we'll talk about all of that when we go over output at some later time. But in terms of getting a connection with, an intuitive feel for your data, when you examine the standardized residuals for persons in your sample, you at that moment are doing the essence of what is done to intuitively, conceptually, by looking at your data, assessing the fit of the model with the data. And so we're going to give a good amount of attention here to what we mean by standardized residuals. The residual, or the error in prediction, is how far off is that predicted value from the model from the actual observed value for each participant on the outcome variable measure. But what you'll actually study, what you'll actually examine, are the standardized residuals, or the standardized errors in prediction, because they are the residuals of your model in standard deviation units. And so that's what you'll actually be examining, are these standardized residuals. So we'll be back to that as we fill this in, or begin to. And then conceptually, I want you to understand the regression equation as being applied to each participant in your sample. Okay? So I want you to understand, conceptually speaking, for helping you understand multiple regression, I want you to visualize, to see, or to imagine the regression equation being applied to each participant in your sample. It'll give you a sense of how the regression equation works, and then from that, how we understand the fit of the model with the data. So, before I show the regression equation in action for each participant, I just want to highlight something for you. And for that, as you know, I go to the blue marker, the tested and true and steady blue marker. So if I was going to give you a pop quiz right now, what I would ask you is, I would say, essentially, what does it come down to in terms of understanding the degree of fit that we have of the model with the data? And your answer would be the following. Your focus would be right here, right here. Right here. Right here. For each participant, as you remember, there are two values on the outcome variable measure, and for evaluating the fit of the model with the data, looking across your participants, what you're looking at is how close overall, across your participants, do the predicted values from the model come to the actual observed values on the outcome variable measure. And the closer overall, looking across your participants, the predicted values from the model come to the actual observed values on the outcome variable measure, then the better your fit. The better the fit of the model with the data. And that essentially is what it all comes down to. All right? So if you're looking at your data set, understand it's these two values that represent the degree of fit of the model with the data. And the closer the predicted values from the model overall across your participants come to the actual observed value on the outcome variable measure, then the better of a fit that you have of the model with the data. So let's just cut to the chase just for a moment here. When people talk about the fit of the model with the data, what they're referring to is how close overall across your participants the predicted values from the model are coming to the actual observed values on the outcome variable measure. And the closer those predicted values come to those actual observed values, then the better of a fit that you have of the model with the data. And that is essentially what they're referring to, is the fit of those predicted values representing the model with the observed values representing the data. The closer overall those predicted values are to the observed values on the outcome variable measure, the better of a fit that you have of the model with the data. Of the model with the data. Of the model with the data. across your participants overall. Okay, so always keep that in mind. Essentially, we're talking about then when we talk about the fit of the model with the data. And now, then, let's go ahead and look at the regression equation. Here's our regression equation. And then within the regression equation, we have, beginning with the constant, the model. Let's apply the regression equation to each of our participants. Okay, so we'll do this, well, we'll go ahead and do this in blue. So we have y hat. So here we have y hat. And that's the predicted value from the model of each participant's score on the outcome variable measure. And that equals A, which is our constant. Well, now let's start filling this in with actual values. So let's say A is 2, so 2 is our constant. Okay. Plus, and let's say that the unstandardized regression coefficient value for job satisfaction, that predictive variable, our first predictive variable in the model, let's say the unstandardized regression coefficient value, B sub 1, for the first predictive variable in the model, is 0.6. So we'll say 0.60. And when we got the measures back from participant 1, we scored them in terms of what their score was on their job satisfaction. And let's say the score can be anywhere from 1 to 20. So 1 would indicate a very low level of job satisfaction. 10 would be a moderate level of job satisfaction. And 20 would be a very high level of job satisfaction. And let's say that participant 1, their score on job satisfaction was 10. That put them at a moderate level of job satisfaction. Okay, and we go plus. Okay, now we're continuing to talk about participant 1 here, and employee salary, and let's say the unstandardized regression coefficient value for our second predictive variable in the model, employee salary. Let's say that it is 0.50. And let's say that we've converted people's salaries onto a scale that is 1 to 20. So if someone in this scale that we've converted their actual salaries to, if they got a 1 on this scale, that means they have a very low salary. And if they get a 10 on this scale, they have a moderate salary. And if they have a 20 on this scale, they have a very high salary. And let's say that participant 1 has pretty high salary. So on the scale of 1 to 20 of salaries, they come in at a 16. Okay, plus. Again, for participant 1, now we're looking at the third predictive variable in the model, B sub 3. This is the unstandardized regression coefficient value for this third predictor variable in the model, positiveness of work environment. And let's say that the unstandardized regression coefficient value for this predictor variable, this third predictor variable in the model, is 0.33. And let's say we can get a score anywhere from 1 to 30 in terms of the positiveness of the work environment. And so if we have a 1, it means that they see the positiveness as very low, which means the negative work environment. At 15, it's a moderately positive work environment, according to participant 1. And if it's 30, then participant 1 has a sees the work environment as being highly positive. And let's say that it's a bit on the negative side here, but not strongly in terms of participant 1's view of the positiveness of the work environment. Let's say that their score on this measure is a 12. If you remember, you get a score from 1 to 30. 15 would indicate a moderate positivity, not quite to 15, 12, so it's a little bit in the negative side. Okay. So now that we have participant 1's scores on each of our predictor variable measures, we can go ahead, along with the constant and understanding the strength and the direction of the relationship of each of our predictor variables with the outcome variable, we can go ahead and we can mathematically generate a predicted value for participant 1 on the outcome variable measure. So let's see, what would it be? Well, 0.60 of 10, so it's 0.60 times 10, it's 0.60 of 10, that's equal to 6 plus a 0.50 times 16, that's half of 16, so that's going to be 8. And then 0.33 times 12, well, that's 1/3 of 12, so that's going to be 4. Okay, so let's find out what the predicted value is. 2, which is our constant, plus 6 is 8, plus 8 more is 16, and 4 more is 20. So the predicted value on the outcome variable measure for participant number 1 is 20. And let's say that the range of possible scores that you can get on the outcome variable measure for organizational commitment, let's say is from 1 to 40. So if you're at 1, you have a very low level of organizational commitment. If you're at 20, you have a moderate level of organizational commitment. And if you're at 40, you have a very high level of organizational commitment. And the predicted value on the outcome variable measure for participant number 1, based on their scores on the predictor variable measures, throw in the constant in there too, is 20, which would be a moderate level of organizational commitment for participant 1, is what is predicted from the model. And let's say that participant 1's actual observed value on the outcome variable measure for organizational commitment, what, as the researcher, we actually scored from their measure when they handed it in, was 25. Well, then the question you need to ask yourself is, how far is that predicted value from the model from participant 1's actual observed value on the outcome variable measure? Well, it's 5 units away. So the residual is 5. And then let's say that the standardized residual, and that involves the formula, et cetera, et cetera. We're not going to be getting into any of that. I'm just going to give you a standardized residual to illustrate a larger point here. Let's say the standardized residual, which is in standard deviation units, let's say it is, and by the way, I'm going to give you the absolute value of the standardized residuals because standardized residuals can be positive or negative. I'm going to give you the absolute value of the standardized residual, so I'm not going to pay attention to sign. Let's say the standardized residual is 1.5. Okay, so that is for participant 1. 2 values on the outcome variable measure. The actual observed value that participant 1 got on the outcome variable measure, 25, and the value as predicted from the model of 20. That predicted value is 5 units away from the actual observed value, so the residual is 5. And just out of my imagination here, have given a standardized residual, which is the residual in standard deviation units, a standardized residual of 1.5. And all of that came from applying the regression equation to this particular participant. Okay, now I want you to bear with me, because if you bear with me, you'll learn some important things about multiple regression and this whole idea of the fit. So let's move on to participant number 2. And we're going to apply the regression equation to participant number 2. Okay, so here we have y hat again. And as you remember, y wearing the hat, getting fancy and getting dressed up with that hat that it wears, that is the predicted value on the outcome variable measure from the model. So that's our predicted value on the outcome variable measure from, well, we'll do it up here, from the model. Okay? Equals 2. You'll notice that value doesn't change as we go from participant 1 to participant 2. It's the constant. It's the fixed value across all of the participants in our sample. Plus the unstandardized regression coefficient value for the first predictive variable in our model, well, it continues to be 0.60 because these unstandardized regression coefficient values are fixed. They're fixed unstandardized regression coefficient values. So they are the same value across all of our participants. So it continues to be 0.60 as we go from participant 1 to participant 2. Now for participant 2, after they handed in their measures and scored by the researcher, we find that the score that they got on the job satisfaction measure was 20. Now, if you remember, that was the highest possible score on the job satisfaction measure. So this is someone who was very satisfied with their job. Okay, plus, again, continuing with participant 2, we have the unstandardized regression coefficient value. Now for the second predictive variable in the model, employee salary, and that continues to be 0.50. Okay, these are fixed unstandardized regression coefficient values. So it continues to be 0.50, it doesn't change. Again, these unstandardized regression coefficient value for each of our predictor variables in the model, they are fixed, so they remain the same across all of the participants in the sample. And let's say on that scale of 1 to 20 on employee salary, for participant 2, they are at an 8, which would be lower than a moderate salary. And then, again, the unstandardized regression coefficient value for our third predictor variable is 0.33. It is fixed. And so it remains the same across all of the participants in the sample. And we got the measure back from participant number 2, scored it, and participant number 2's score on how they perceive the positiveness of the work environment was, let's say it was 21. And there's a range there of 1 to 30. They seem to be on the more positive side in terms of their perception of the work environment. Okay, so let's see what the predicted value is now on the outcome variable measure coming out of the model for participant 2. Well, 0.60 of 20 is going to be 12 plus 0.50 times 8, half of 8, going to be 4, plus 0.33 times 21, or 1/3 of 21, is 7. So let's add them up. We got the constant, which is 2, plus 12 is 14, 4 is 18, 7 is 25. So the predicted value for participant number 2 out of the model is 25. And let's say that for participant 2, their actual observed value in the outcome variable measure was 35. Just looking at that, that looks like the predicted value is a good distance away from the observed value. The residual is 10. Predicted value, 10 units away from the actual observed value on the outcome variable measure. So the residual is 10. And here the standardized residual, let's say, is 2.3. As we'll talk about later, that's a pretty large standardized residual. That does suggest that the model, as it concerns participant 2, didn't do a good job at predicting the actual observed value on the outcome variable measure. Seems to be off there more than we would like. Okay, now here's what I want to point out to you. And in fact, but before I do that, I'm going to point this out to you, and then I'm going to do one more time for participant 3. But what I want to point out to you right now is that notice what is creating the variance in the predicted values. And when I talk about the variance in the predicted values, I'm talking about how they vary from one another, from participant to participant. Here the predicted value is 20 for participant 1. Here's 25 for participant 2. So that's in a small example way here, just between these two participants. That is what we mean when we talk about the variance, okay, between these two participants now. We normally would be talking about the entire sample, but just looking at it for these two participants, this is the variance, or how these predicted values vary between these two participants. Notice what that variance is based on when you look at the regression equation. It's not based on the constant, right here. It's not based on the constant. It's not based on the unstandardized regression coefficient value for predictive variable 1, or the unstandardized regression coefficient value for predictive variable 2, or the unstandardized regression coefficient value for predictive variable 3 in the model, because they're the same between participant 1 and participant 2. That is not giving you the variance in the predicted value between participant 1 and participant 2 because those values do not vary from participant 1 to participant 2. What does vary and what gives you the variance in your predicted values, not only between participant 1 and participant 2, but across all of the participants in your sample, are their scores on each of the predictive variable measures. Those do vary from participant to participant. In this case, for participant 1, we go from 10, participant 2 go to 20, 16 to 8, 12 to 21. So yes, in producing the predicted value from the model for any one participant, we've got the whole model involved with all its different components. When it comes to the variance in the predicted values from one participant to the next, what gives you that is the variance across your participants in their scores on the predictor variable measures. So in that sense, and that's a crucial sense, because you see it's from the variance in your predicted values that you're seeking to reproduce as well as you can the variance in your actual observed values on the outcome variable measure. And the more of that variance in the actual observed values on the outcome variable measure that you can reproduce or capture with your variance in the predicted values from the model, then the more of that variance on the outcome variable measure that you're accounting for or explaining, or the better of a fit that you have of the model with the data. And what does that all come down to? When we talk about variance on the predicted values from the model, the variance across your participants on their scores on the predictor variable measures. And we're seeing how well that variance can account for or explain variance on the outcome variable measure. And so in that way, we're asking, well, how much of that variance on the outcome variable measure can we account for or explain by the model, i.e., can we account for or explain by variance across our participants on the predictor variable measures. So it's this variance across your participants in their scores on the predictive variable measures in the model that has given you the variance across your participants in the predicted values coming out of the model. And the closer that variance comes to reproducing or capturing the variance of the observed values on the outcome variable measure, then the better we say, or the more we say, of the variance on the outcome variable measure that is accounted for or explained by the model. And the better of a fit that we have of the model with the data. Let's do it one more time. Participant number 3. Apply the regression equation to participant 3. Y hat. This is the predicted value on the outcome variable measure from the model equals, well, you can do this with me now, right? I mean, we're like in sync now. We're like simpatico. We can like do this together now, okay? So, what's the constant? Well, you know, because it doesn't change from participant to participant, so it continues to be 2 plus the unstandardized regression coefficient for predictor variable 1, You know what it is because it doesn't change across your participants, so it continues to be 0.60. Now the score is very likely to be different that we have for participant 3 after we score their measure on job satisfaction. And so now let's say we're talking about a score of 5. And so here the job satisfaction is quite low for participant number 3. And then plus, well again, you know what the unstandardized regression coefficient value is for predictive variable number 2. It's the same as we've seen before for participant 1 and 2. It doesn't change, so it continues to be the same for participant 3, so 0.50. And let's say on the scale of 1 to 20 for employee salary, you got an 18. Didn't do that too well, did I? Okay. And then plus. Well, the unstandardized regression coefficient value for predictive variable number 3 continues to be the same as we saw for participant 1 and participant 2. It's fixed, it does not change. So it's 0.33. And let's say that person, we got their measure back, we scored it, they got a score of 6. And that would be quite negative view, their perception of the work environment. Okay. The scale of 1 to 30 that we had for positiveness of work environment, this is a 6. Okay, so what is the predicted value coming out of the model for participant number 3? Well, 0.60 times 5 is 3. Plus 0.50 times 0.50 times 18, or half of 18, is 9. Plus 0.33 times 6, or 1/3 of 6, is 2. Okay, so here we have 2, plus 3 is 5, plus 9 is 14, plus 2 is 16. So here the predicted value out of the model for participant number 3 is 16. And let's say their actual observed value on the outcome variable measure was 14. That's looking pretty good, isn't it? Just looking at it. A predicted value coming quite close to participant 3's actual observed value in the outcome variable measure, just being 2 units away. And let's say that standardized residual is 0.32. That's a low standardized residual, and we like that because that indicates that the predicted value out of the model is coming quite close to the actual observed value on the outcome variable measure, in this case for participant 3. And again, notice what is producing the variance in our predicted values coming out of the model, and what will continue to be producing the variance among the predicted values coming out of the model across all of the participants in the sample. It's not the constant. It's not the unstandardized regression coefficient values, because they're the same across all of our participants. What's creating that variance in the predicted values coming out of the model, now looking across our first 3 participants, 20, 25 to 16. So that variability or variance in the predicted values coming out of the model are person scores on the predictor variable measures. 10, 20, and then 5, 16, 8, and then 18, 12, 21, and then 6. Those are the only values that are varying from participant to participant, and thus they are creating the variability, the variance in the predicted values coming out of the model. And again, the greater the degree to which the variance among our predicted values across all the participants in our sample can reproduce or capture the variance of the actual observed values on the outcome variable measure across all of our participants, then the more of that variance on the outcome variable measure that can be accounted for or explained by the model, or in other words, by person scores on the predictor variable measures, which are in the model. Okay, now, there you are. You are with family and friends. And you say, hey, what I got to do is I got to leave for a bit. I'll see you later. It's been a nice conversation. But I got to go now because I got to go ahead and I got to examine the standardized residuals. You'd probably say I need to examine the residuals, but what you mean are the standardized residuals for the people in my sample, because I want to get an intuitive sense, just looking at my data, as to what the fit of the model is with the data. Or in other words, how close overall across all of my participants the predicted values from the model are coming to the actual observed values on the outcome variable measure. So I got to go now. I'll see you. I know there's a lot, but I got to go examine the residuals, standardized residuals. So I'll see you. Okay. Bye. See ya. Bye. Bye. Okay. Well, okay. I'm actually not going to leave. So you go ahead. You go into the other room, and you start examining these standardized residuals. Now, of course, this goes on. Okay. You keep doing that across all of the participants in your sample. But let's just go ahead and look at it for these three. We can't do a lot with three, okay? So, you have to extend it in your mind for this presentation. It going on and on across all, say, 100 people in your sample of all these standardized residuals you're examining. And in examining those standardized residuals, what you can do to just get an initial sense of how well the model is fitting with the data is that you are looking for the number of standardized residuals. And so there's a particular benchmark I'm going to relate to you here. You're actually looking for the percentage of the standardized residuals, let's say across all 100 participants in your sample, the percentage of those standardized residuals across, let's just say, the 100 people in your sample that are greater than 1.96. Now, looking across these first three, we have this one standardized residual that's greater than 1.96. And I'm talking about, by the way, the absolute value. The absolute value. So we're disregarding sign here in terms of whether it's a positive standardized residual or a negative standardized residual. We're talking about the absolute value of the standardized residual. So we're not including sign here. Looking at the absolute value of the standardized residual. And just looking at these first three, we have one instance of where the standardized residual, the absolute value of the standardized residual, is above 1.96. In this case, is 2.3. And that indicates a particular instance. In this case, it's participant number 2, but we really aren't concerned with individual participants. We're concerned what this looks like across all of the participants in our sample, but right now we'll focus in on participant 2. If you have a standardized residual that is greater than the absolute value of 1.96, that indicates that we have a predicted value out of the model that is a good distance away from the actual observed value on the outcome variable measure. Indeed, it appears to be. This predicted value seems quite a distance away from the actual observed value for participant 2 on the outcome variable measure. But here, where our standardized residuals are less than the absolute value of 1.96, especially here, 1.5, that's less than the absolute value of the standardized residual, 1.96, but it really is less than 1.96 here with participant 3. That indicates that you're getting closer to, you are here with participant 1, your predicted value is 5 units away from the actual observed value, the outcome variable measure. Here with 0.32, and that's considerably less than the absolute value in the standardized residual of 1.96. That's heading toward 0. I mean that's a low number. And here we're getting real close. Predicted value out of the model and the actual observed value on the outcome variable measure for participant 3 in this case, 2 units away. Represented by that low standardized residual. Okay, but again, you're not looking at this in terms of individual participants. You're examining these standardized residuals across all of the participants in your sample. And if you see a situation where more than 5% of your participants have an absolute value of the standardized residual that is greater than 1.96, so if you have 100 participants in your sample, it's more than 5%, that'd be more than 5 people. That is an indication, just an indication. You're going to know much more precisely when you actually run your analysis. But just looking at your data, that is an indication that you may have a poor fit of the model with the data. That overall, looking across all your participants, you may have a situation where the model is not doing a good job in the predicted values that it's generating based on person scores on the predictive variable measures at accounting for variance on the outcome variable measure. Those predicted values just don't seem to be coming that close to the actual observed values. The variance on these predicted values do not seem to be capturing much of the variance on the actual observed values. So your model really is not telling you much. There's an indication of that. You'll look at your actual output to know more certainly and more exactly. But there's an indication here that your model is really not telling you much in terms of person scores on the predictive variable measures about person scores higher or lower, about variance on the outcome variable measure. But if you look across all your participants in your sample and you find that less than 5% of your participants, less than 5 people here in this case, across your 100 participants in your sample, have standardized residuals that are greater than the absolute value of 1.96, especially if those values are below an absolute value on the standardized residual. If you have just a large number, let's say most, let's say, okay, that are below 1, let's say below 1. If they tend to be around 1.3, 1.5, 1.7. It's not getting larger than an absolute value of 1.96, but it's certainly not as low as 0.32. Okay? If you're getting down below 1 for, a large number, okay? Let's say, definitely most of your participants in your sample, you're getting below an absolute value of the standardized residuals below 1. Well, that indicates that's a much better sign, okay? Just looking at your data regarding the fit of the model with the data, that's indicating that overall across the participants in your sample, that your predicted values coming out of the model, they're coming pretty close overall. And that doesn't mean that's the case for any particular participant. Certainly it didn't happen here with participant 2, for example, but looking across all the participants in your sample, all 100 of them, let's say, so overall, that would suggest that the predicted values out of the model are coming pretty darn close to those observed values on the outcome variable measure across your 100 participants in your sample, let's say. And that would indicate that you perhaps have, again, you've got to do the actual analysis and see what the analysis has to say, but that would suggest that you may have a model that fits good with, they talk about good fits, so you have a model that is a good fit with the data. And when you're saying that, and if that actually turns out to be true when you run your multiple regression analysis and you look at your output, what that's telling you is that these scores on the predictor variable measures in the model have a lot to tell you about persons' higher and lower scores, about what characterizes people with higher and lower scores on the outcome variable measure. A good fit of the model with the data. So examining these standardized residuals, just intuitively to get a sense of your data, how well the model fits with your data, that's what statisticians initially do. They want to get that sense of their data by looking at it. So they examine these standardized residuals, and they can get that initial sense of how well their model is fitting with the data before they run their actual analysis. Okay, so now let's talk about what we mean when we talk about the fit of the model with the data. What we're saying is how close overall across all of the participants in our sample are the predicted values from the model coming to the actual observed values on the outcome variable measure. That's what it translates to. The fit of the model with the data is how close overall across all the participants in your sample are the predicted values from the model based on person scores on the predictor variable measures. And so understood in terms of person scores on the predictor variable measures, coming to the actual observed values, the data, on the outcome variable measure. The fit of the model with the data. So there you have it. That is what we're seeking to know about our model, is how well does it fit with our data. And the better it fits with the data, then the more the model has to tell us about people scoring higher and lower on the outcome variable measure and the particular construct that measure represents, in this case, organizational commitment. So if we have a model that has a good fit with the data, indicated by the standardized residuals, if you're examining it yourself, being low for the most part, certainly below an absolute value of 1.96, tells you those predicted values from the model are coming close overall to the actual observed values on the outcome variable measure. That is telling you that your model, or person scores on the predictor variable measures, which are in the model, has a lot to tell you about how people are scoring on the outcome variable measure. And that's what we want. We want a model that does that does a good job at predicting people's scores on the outcome variable measure, because then we can say we have a good fitting model. And from a good fitting model, first of all, we now understand better, in terms of those predictor variables in the model, why people score as they do, or what influences how people score as they do, higher and lower scores, on the construct as measured by the outcome variable measure. So we have a better understanding of that now in terms of the particular predictor variables in the model and how people score on those predictor variable measures. So we have a better understanding of what influences people's scores on the outcome variable measure, and if we have a reliable and valid outcome variable measure, what is influencing people being at higher and lower levels, in this example, in their organizational commitment. And we're also in a position, if we choose to go beyond regression as an explanatory tool, to then start to use the model for purposes of prediction or as a predictive tool. I will have more to say about that later. So thank you. Oh, my producers are signaling to me I have one more thing to do. Okay, so let's just take a moment here and let it sink in as to what we mean when we talk about the fit of the model with the data. I want you to have a clear sense of that. Let that sink in. I've had a lot to say about it. Let what I've said sink in for a moment here, and then I'll go on to the next part, which is my signature, because my producers have decided that I should sign these things. Okay, I'll go ahead. I'll humor them. I'll sign it. Take a moment to have this material sink in. The fit of the model with the data. How close are predicted values from the model are coming to the actual observed values on the outcome variable measure. The fit of the model with the data. Do we have a good fit? Moderately good fit? Poor fit? That's what it's all coming down to when we talk about the fit. And now with that in mind, onto the signature. Let's do it. Let's see, can I do it over here? Okay, very good. Here is the signature. I guess we're going to be calling this the signature series. I don't know what we'll be calling it. But it does have my signature on it. And of course, when I'm talking with you about regression, I always do so in a very happy way, because how I can help you get down to the essence of regression, and this idea of the fit of the model with the data is really at the core and the heart of the essence of regression. Now that you understand what is meant by that phrase, you're at the core, you're at the heart of understanding multiple regression in terms of building a model that is a good fit with the data. That's a process to do, but you'll get there. So I'm very happy talking with you about that. And of course, I always like to put the hair in. Now, my producers were very concerned before I started doing this video. They're very, delicate with me. They go, your hair has a mind of its own right now, right? Or it's going in different directions because it can't decide where it wants to go, as opposed to just saying my hair is a mess. So we don't have like anybody to, comb my hair around here, okay? So the producer actually came over and started arranging my hair so I could, look A little bit better, I suppose. But I want you to see how I looked before the camera started rolling. So it was kind of like this. And then I had like some hair over here, so it didn't really know where it wanted to go. And there was like some hair like down, like that. So that's how I was looking before the whole thing started. I probably look that way again now at this point. I've been talking with you for a while. Hair kind of, here, I'll do it for you, see? Here, I'll do it for you. Now you can see it more in live action. And, okay, so there we go. So we'll go there with that, and then I wear glasses, so we'll put some glasses on. This is better than one I did recently. I looked like, I don't know, I looked weird, odd. I don't know if this helps much, by the way. That's supposed to be the rims. Okay, well, that's how I looked before we started taping. So I hope there was some improvement by the time they got through with me. And there you go. So my signature and some rendition of how I looked before the taping actually began. Love presenting to you, talking with you, discussing regression. Until we meet again.